The base catalyzed hydrolysis of an ester, also known as saponification, is another way to convert an ester into a carboxylic acid. Now, the other way is the acid catalyzed hydrolysis, which there's a video on that, so if you need to know that, go check it out. And the main difference is, other than it's conducted with a base versus an acid, is that this is an irreversible transformation. Unlike the acid catalyzed hydrolysis, which is reversible because it's essentially a Fischer esterification backwards conducted in the same conditions. So the reason this is called saponification, it sounds like soap, right? And because that's where it comes from. Because lye is used to make soap, and lye is essentially sodium hydroxide. And what they do is they take animal fats, which are just these long chain esters like triglycerides, you mix it with lye, and you get like these detergents, these carboxylic acid salts, these surfactants, and that's essentially how soap's made. Broad strokes. I don't actually know how to make soap. I couldn't give you a recipe. That's why it's called saponification. So a lot of times now in teaching, you'll hear it called the base catalyzed hydrolysis, but there is that old-timey word that some people still use called saponification. So just know that that's the name. So what's the first thing that happens here? We have our sodium hydroxide that looks like this. And our hydroxide ion is going to come in, nucleophilically attack that carbonyl carbon. We're going to kick those electrons up onto there. We're going to make this tetrahedral intermediate where we have this anion on our alcohol. We have our OH, and then we have what was part of our ester. Now this is going to collapse back down. We're going to push our electrons here. We're going to kick off this alkoxide, and we're going to form this carboxylic acid right here. There, we did it, and also our alkoxide. You must be thinking to yourself, wow, that was really easy. We're done. Not so fast. So yes, we took our ethyl acetate. Yes, we just made acetic acid right here. Except what did we just do? We just made an alkoxide. Now, an alkoxide is very basic. So what is it going to do? It's just going to rip this proton here from the acid we just made. So what we're going to do is this is immediately formed, then it's essentially immediately attacked and deprotonated into this carboxylate. And this is the form that existed. And now once we've gotten here, this is not going back the other way. Imagine if we had an alkoxide attack this. What would this look like? Because we have to kick those electrons up, right? We'd have an anion up here. We'd have an oxygen with a minus there. And then we'd have this. We have a dianion. That's so unstable. That's not happening. Additionally, this is very stable because remember, we can move this bond around if we want, okay? And we can share this through resonance, this charge. This charge is delocalized kind of along this whole thing, making this very stable. So in reality, while we make this, it's immediately deprotonated into a carboxylate salt. So when we just say sodium hydroxide, it's slightly misleading because in real life, what you then have to do is hit it with some HCl, give it a nice acid workup, and you'll get your salt right back. And I've run these in real life. They're pretty easy. They work quite well. Remember when you run these, you do usually run it in an ethanol water mixture, and that ethanol is to help solubilize the ester because esters like ethyl acetate is not miscible with water. So you need that kind of as a co-solvent to help things work out. Additionally, I've used THF as well. And it's really neat with the THF and ethanol in one because when it's in this carboxylate portion, at least for me when I did it, it was a clear yellow solution. And then I dropped in HCl and it just came crashing out. It was so cool. And then you just filter it, throw it in a set funnel, do ethyl acetate. Not ethyl acetate. Extract it with diethyl ether, and then vap that ether off. Boom, you got your carboxylic acid. So if you want to get more organic chemistry learning, be sure to hit that follow button.